let's talk about nets of solids. Okay, so if you imagine that I cut out this shape, okay, and I marked these divisions on it, and then I marked some dotted lines here, 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 and here. And if I was to fold along those lines with a little cross on them here, the ones I've just mentioned, okay, I would get this shape here, okay. So this is a net of this solid, okay, and there are 11 possible different nets for a cube. There's 11 different ways of drawing this shape that we can refold into a cube, okay. So here's an example now. Given the net of an open box, it's like the two-dimensional version of the 3D solid. That's really what a net is. Find the volume, okay. So you have to visualize how to reform that box by folding along the dotted lines to get this shape here. Length, breadth, height. So the volume is 14 by 8 by 3 is 336 centimeters cubed, because we're talking about volume, okay. And if we want to find the surface area, that's found by multiplying 2 times 14 times 3 plus 2 times 8 by 3 plus 1 by 14 by 8, because there's no top part of the box. Okay, we look for the surface area. And our answer to that is 244 centimeters squared, because we're dealing with the units of area. Okay, and here's another example here. Will I come to that? No, we'll start here first with capacity. Okay, the capacity of a container is the amount of liquid that it can hold. Okay, and the units of capacity are litre. 1 litre is the same as 1,000 cubic centimetres. Okay, and we met the 1 cubic centimetre in the last video, where it was 1 by 1 by 1 centimetre. Okay, well, 1,000 of those gives you a litre. And basically, if you had a shape that had, if you had a cube of side 10 centimetres, that's 10 by 10 by 10, that's 1,000 centimetres cubed, that's a litre, okay? And if you want to convert cubic centimetres to litres, you divide by 1,000. So let's look at this example here. The rectangular container on the right, is from question 21, page 105. The rectangular container on the right has a capacity of 4.8 litres. Find the volume in centimetres cubed, not litres. So let's do that now. 1 litre is 1,000 centimetres cubed. 4.8 litre equals x centimetres cubed. Okay, so that's what we're looking for. Cross multiply. X by 1 is 4.8 by 1,000. So x is equal to, or the volume in centimetres cubed is equal to 4,800 centimetres cubed. Okay. Now we have to find h, this unknown. So the volume is equal to 20 by 30 by h. So we equate 4,800 equals 20 by 30 by h. H must be equal to 4,800 divided by 20 by 30, which is 600. Those two will cancel out, and 6 goes into 48. H is equal to 8. Okay, let's talk about prisms. Clear a bit of this stuff. So, what is a prism? A prism is a solid figure with the same cross-section along its length. So if you look at this shape here, that's the cross-section, and it's the same all the way in the background there, along this length here. So there's your cross-section, and there's the length, and it's the same shape all the way through. That makes it a prism. Here's another prism. There's the cross-section shaded there. Here's another one, cross-section. Here's another one with cross-section as well. And this is the, we can find the area of that cross-section, or the area of that, or the area of that, or the area of that. And the volume then of these prisms is equal to the area of the cross-section multiplied by the length. So it's all those go like that. Okay? How many of them? Area of the cross-section multiplied by the length. And just to mention then, a right prism, there's a prism and a right prism is a bit different. The right prism has the top face vertically above the base, and in this case with rectangles. So if you can imagine looking down, that's known as a right prism. If you were looking at that from side view, it would look something like that. Looking down on it, looking from the side view on it. That's known as a right prism. Okay. Find the area of the triangular cross section of this prism, hence find the volume of the prism. So here is the cross section. You need to find the area of that and then multiply it by that. Okay, so what are we looking at here? We're looking at a triangle of 8 and height 6. So our area for the triangle is half the base by the height. So it's a half by 8 over 1 by 6 over 1. I like to do it like that, keeps it balanced. 2 will go in there 3 times, and 3 times 8 is 24. Now to find the volume we need to multiply this 24 by 10 here, the cross-section area by the length, so the volume is 240 centimetres cubed. Okay, and it's just important to note then that the surface area of a prism is the sum of the area of all its faces. So if you want to get the surface area of this prism here, you'd get the area of this, and you'd count the one in the back, you'd get the area of this, you'd count the corresponding one behind here, and then you get the area of the one that's sitting on the page. Okay, let's look at scale drawings. Okay, scale drawings are the same shape as the object they're depicting, but are a different size. Obviously they're smaller generally, but sometimes they can be bigger too. So the scale tells us the length of the drawing in relation to the real length of either the building or the microscopic part for the computer is. Okay, and if we're told that the scale is 1:100, that means the real size is 100 times the drawing. Okay. So scale determines the size of the drawing. So a 1:10 drawing is bigger than a 1:100 drawing of the same object. Okay, so if you're drawing a building and you use a 1:10 scale, then you need a pretty big piece of paper because any measurement on that paper at 10 times that is the wall or the window or the whatever. Okay. So, okay, well here's an example then. This, because we use scales on maps, we use them everywhere really. You can see them on toys and all sorts. Anyway, the scale on a map is 1:100,000, okay? Find the distance in kilometres between two towns which are 7 centimetres apart on the map. So this scale will be 1 centimetre to 100,000 centimetres. And then two train stations are 25 kilometres apart. How many centimetres apart are they on the map? Okay, so the solution is, you say, the scale is 1:100,000, 1 centimetre is to 100,000 centimetres. So 7 centimetres must be equal to 700,000 centimetres. That's multiplying both sides by 7. So therefore, that's the same as 700,000 centimetres, the same as 700,000 divided by this centi here, which is here. So they'll cancel the two zeros, and you get 7 centimetres is equal to 7,000 metres, which of course is 7 kilometres. Okay, and given that 1 centimetre part 2, 1 centimetre is 1 kilometre. How far on the map is 25 kilometres? You know, what's that represented by? We just put one over the other, and you cross multiply. So you get x by 1 is equal to 1 times 25. So x is equal to 25 centimetres on the map represents 25 kilometres.